So in my last video about this rebar shelf, I had a lot of comments that correctly addressed the point that rebar can contain a lot of carbon and in turn cause brittle welds, which is true. But I want to show you what wire I actually used and what gas. And I want to weld one piece together and stress test it, bending and impact test to see what actually happens under load. And well, I leave it up to you to determine if this is good enough for a shelf like this or not. Let's get into it. So here's the deal. Standard rebar isn't made to be welded, it's made to be cast into concrete, and they expect it to be durable and cheap, and therefore they can add a lot of carbon to it, and it varies tremendously by batch. So weld this with the wrong filler wire and your weld is going to be brittle and breaks under load. But here is why I think my welds hold up. I'm using straight CO2, the same stuff that is in your soda, no expensive argon or argon mixes, combined with Lincoln Outershield 71M. And I've been using this wire since years. It's made for shipyards where unknown materials are being combined in unknown conditions with wind and paint, and it really holds up. I can weld through a painted surface on an old rusty piece of iron. As soon as the wire finds contact, it's gonna burn through and clean the whole area up, and I still get a beautiful weld. It's truly amazing. Highly recommended stuff in case you want to invest. The downside is it requires a quite expensive welding machine because the voltage requirement is higher than on standard MIG wire. It requires more than 20 volts if I remember correctly, and there are not many compact MIG welding machines that can do that. But there should be an equivalent to this welding wire for cheap $60 stick welders. And if you're interested, let me know in the comments. I would love to make a comparison video about that, how this wire holds up, or well, the cheap MIG welder, the cheap stick welder holds up to this setup here. Okay, so let's get into the test and we'll see what we get. And this is how I weld rebar together when I have to join them at the cut. I leave a gap of like 3/16 or 5 millimeter. Around 5 mils, yeah. 3/16. And the reason for that is that the weld puddle can penetrate in the center of the rebar. If we join them like this, the weld will only be on the outside, and we have like a crack below it, which is this gap here, and the welding wire cannot really penetrate to the center of the material, making it really weaker. So some people add like a cone to the part, but I never do that. They add a cone on both ends of the round material or square in order to get full penetration, but that's much more work, so I always do it like this. You decide what you prefer. Okay, so I start by adding just a spot weld on one side, and then I turn it and give full penetration from the other. Okay, short tack. Oh, now we got a wind gust, of course. Here we go. Now I turn the whole thing. This was not ideal, but you see where I'm going. And now I'm gonna fill this gap here, going full power. Yeah, and that's that. Not beautiful, but good enough for a test. So here's our ugly weld, but that is even better for this video because we want to prove that a quick dirty weld can really hold on rebar or not. So, but On the other hand, this is actually how I built the whole shelf. I didn't really, you know, look for beauty in the weld, and I let it cool down now. It's still quite hot. And then we're gonna stress test this thing and see where it goes. First test, impact. Using this little hammer here. So far so good. Followed by a bend test. See, the rebar is not bending at the weld, it's bending elsewhere, even after the impact test. And that's how I experienced this in the past. You have to put in consideration how hard I hit it with the hammer already. So if this was brittle, a brittle weld, it would have already cracked just by hammering it. So I tried to get the bend maybe closer to the weld. Let's see if we can break it now. Which, you see what's happening? Yeah. I don't know about you, but I call this acceptable for building a shelf. All right, and I think I'm gonna weld another quick piece with a T connection just to prove the point. So I mentioned to you how great this wire actually is to go through paint and rusty material. I wanna show you with this old piece of rebar that I'm gonna weld to a even older painted old piece of a swing, I think. And I will shoot right through this area here without grinding, just to prove a point. All we need is the wire finding contact somewhere, which it usually does, and then it's gonna weld. And then we do some impact and bend tests, just to show you what I mean. All right. One, two, three. Found contact. Now I don't see anything. Okay. Yeah, look at that. Let me get a something galvanized to show you, to weld this onto here. Ugly galvanized piece of metal. Usually impossible to make weld without grinding first, okay? Look at that. Amazing. Okay, let's put our rebar to the test. I'm first gonna hit it with my hammer, and then we bend it. Also this. Yeah. And let's bend it. I think that's pretty convincing, isn't it? So I'm sure if I bend it several times, it's gonna fail, which is normal, especially high carbon, because it's gonna be harder here. But again, I'm just building a shelf, so a shelf is never gonna bend more than once, because then I'm gonna throw it away. So I conclude for my build, so I'm not telling you to weld whatever rebar you have laying around with whatever welding wire. What I want to get to is you have to test what you have, do exactly what you've seen in this video, and determine if that is good enough for you or not. I mean, in my case here, this is completely appropriate for what I'm building, what load I try to apply. A piece of rebar welded to somewhere is not going to bend more than once in one direction if something should fail, because then obviously I know it failed. So yeah, what you have to do is weld a sample joint, put it in a vise or wherever you want, in a hole in the concrete, whack it with a hammer before and bend it and determine if it's good for you or not. This is another rebar shelf I built, 20 foot long for below than 200 bucks. And look at that. I weigh more than 200 pounds, 225 or something. And this is 55 inch in span. That thing, I think, holds. And let's add some more weight to it. 55 pounds. Yes, so if you're interested, like and subscribe. This video, how I built this shelf, is coming up soon. And let me know in the comments what you think about my crazy endeavors. Oh, and this turns out to be quite comfortable, actually. Another idea, container bunk beds.